Good morning. Good morning. Thank you all for coming. It's a pleasure to be back at CDNLive EMEA yet again. So I lead the custom IC package, and PCB R&D teams at Cadence. We're about 1,100 engineers strong, doing lots of software development, being pushed very hard by the mixed signal community and your expertise here in Europe, and we appreciate it very much. We appreciate your partnership with us. Now, you might think this is a bit of an odd title for a CDNLive keynote. Where are the flying automobiles? It seems, given all the talk today about the driverless car, it seems as though maybe tomorrow you'll walk out to your mobile living room on wheels. You'll get inside and you'll say, "Alexa, take me to Frankfurt." You'll then relax or work or sleep or daydream, like some of you might be starting to do right now. But what you won't do is you won't get into that comfortable mobile room and say, "Okay, Google, take me to San Francisco." That will still be a flight. Now, personally, I still like driving a car and being on the open road and having a powerful motor. How many of us enjoy that airport experience? Maybe going through security and boarding the plane, and if you're fortunate enough to be on United, you can be exited off the plane. That wonderful cuisine. I just wonder if we're solving the right problem, personally. Be that as it may, there's little doubt at all, that the integration of advanced electronics with complex software is changing industry after industry after industry, including automotive, IoT, and more. And all of this is made possible by the pioneers before us, the men and women before us who were willing to take that leap of faith, to look outside the box, to take the path less traveled, like William Shockley. Many of us know him, don't know him personally, thank goodness, but those of us that do, he invented the transistor in 1947 at Bell Labs, and he was surrounded by a number of very, very talented engineers. They left the lab of their Nobel Prize-winning mentor in the late 50s and formed an iconic company called Fairchild. Now, we know that Fairchild was acquired earlier this year by ON Semiconductor, and I do hope that name lives on in some way, shape, or form. But this prestigious group then dispersed yet again, and yet more companies were formed, right? Intel, National Semiconductor, Teledyne, AMD, and more, all came out of this group. They have set the stage for you to be the next Shockley 8, and that's what we'll talk about today a little bit. Now, at this time, I was just a little tyke. This is the early 60s now. I'll let you guess which of the Beckleys was me. Toys for tots in those days were far less advanced, I can assure you that. But there's something prescient, I think, about the Etch-a-Sketch. Many of you probably recall it, right? It used sand and it used magnetics. Now, in the early 60s, I can remember with my siblings watching that black and white cathode ray TV with lots of vacuum tubes in it. And there was a popular cartoon series called The Jetsons. Some of you may recall it. I don't know if it was popular in Europe or not, but in the early 60s, the Jetsons predicted smart watches and robotics in the home and FaceTime and the ability to get information or news any place, anytime, on flat screen TVs and other devices, and to have online medical records and remote diagnoses and more with sensors and the like. And every episode included the personal flying vehicle. We got everything else here. Where's my flying car? That's your challenge, right? And I will posit to you that the step to the autonomous vehicle will be followed by yet another step. And what I'd like to do is talk to you about the tools and technologies that Cadence is enabling to help you change the world. I talked about the integration of complex software and advanced electronics. We've seen waves of computing come by on the mainstream side of the equation, all the way into desktops and laptops and phones, cell phones, and then mobile phones, right? But it's just the tip of the iceberg. And so we'll see in a decade the number of units, of IoT units that use that cell phone as a personal computing hub go up by 6x, from 4 billion to 24 billion units. That's stunning when you think about it. We'll see other areas transform as well. The combination of advanced node design for CPUs and GPUs, layered in with next generation embedded flash and SRAM and 3D memory technologies, is already starting to enable machine learning and deep learning and eventually cognitive learning. And there we'll see growth from the very, very small millions of units in industrial robotics especially and consumer into the billions of units. And for today's topics, of course, the driverless car. It seems from NXP, our guest speaker today, into Tesla, into NVIDIA, into Uber. Seems as though every semiconductor company and practically every software company sees opportunity in the driverless car. And here we'll see, for semiconductor content alone, an almost 4x increase. And of course, we know that the number of units will be huge. So think about just this small subsection and what the opportunity is for your products in the future, for the systems and the products that will be created for the software and more. From the cloud through the fog to the edge, we see system design enablement unfolding. And that's why Cadence is transforming ourselves to be more relevant for your world, where you have software and hardware teams working together. At the cloud level, we see silicon photonics for those high-speed communication links. We also see, at the edge level, ultra-low power devices. And those low-power devices will have to last for years and intermittently send information up into the fog and cloud. But at the same time, we see exceptionally high-performance devices with embedded sensors and embedded memory that are very high power and are processing lots of data real-time while communicating with the cloud as well. For those types of SoC applications, we have Cadence's IP. We have our design platforms, Innovus and Virtuoso. For the package and board, we have Allegro SIP, Allegro PCB. For simulation and verification, and for system analysis, we have tools like our hardware platforms, Protium and Palladium, Jasper, Excellium for digital simulation, Spectre, AMS Designer, and then Sigrity for system level analysis and more. So Sanjay made a comment about the Virtuoso platform. I feel like I've inherited one of the iconic names in the industry for electronic design automation. As it turns out, when I was at Harris Semiconductor back in the early 80s, I actually worked on this platform because it was actually bought by Solomon Design Associates, which then merged to become part of Cadence. God help you if any of my code is still in that product. I don't think it is. But the good news is that the number of people doing advanced node design is stunning to me. I can remember 4 or 5 years ago talking to the board of directors of Cadence, and they said, Tom, 22 nanometer FinFET is just unfolding. How many companies do you think, maybe 5 years from now, which is about now, will be doing FinFET-based design? And I said, a few dozen. I was wrong. So in this platform, for 20 and 16, 14, and 10, and now 7, more than 130 different companies. Hundreds and hundreds of design teams, thousands and thousands of users. Why? Because of the opportunities we talked about, right? They're unfolding, and it's just the beginning of this journey, pioneered by those guys before, the Shockley 8 and others, right? So we can handle, all of the parasitics and the challenges. We don't do it in a vacuum. We work closely with foundries like TSMC. We work very closely with you, who are pioneering technologies and methodologies to handle all the rules and multi-patterning until EUV can kick in. Last year, we introduced a new family of analog design products, Virtuoso ADE Explorer, Assembler, and Verifier. Explorer and Assembler are optimized for single test bench and multi-test bench design. They can handle the large amounts of data and parasitics and corners that you have to deal with at advanced node design, but also for very high performance and very highly tuned analog. Verifier is the first analog verification tool to come to the industry. We're really pleased about that. It can handle functional safety requirements and traceability for your analog to try to catch up with the digital side of the equation. When you combine it with Excellium on the digital side and AMS Designer, you have a mixed signal verification environment that's unfolding to kind of track your products. In a year, more than 100 companies are in various stages of deployment. It shows you what's unfolding and the opportunities that people see. In February of this year, my colleague Anirudh Devgan, he runs all of the digital R&D teams, both for sign-off and verification and implementation at Cadence. He introduced a new digital simulator called Excellium. The first thing he did was he optimized Incisive for single-core performance. Then he combined it with the RocketTick multi-core logic simulation capabilities. And together, that new unified product can provide 5x or more in performance improvement depending on the type of design. Last month at CDNLive Silicon Valley, Cadence introduced a new DRC system, Pegasus. Pegasus was built from the ground up over the last 5 years at Cadence. It's built on the cloud. It's built with a massively parallel architecture. It scales on hundreds and hundreds of CPUs, upwards to 1,000 or more. It's fully integrated with Virtuoso and Innovus, both for interactive modes, and it reads PVS decks. Now, qualification at the foundries is underway at TSMC, at GF, at ICF, at Samsung, and more. But think about doing a DRC turn in a matter of hours versus days or weeks, and what that means in terms of getting your product to market faster. Today, there are 2 announcements. This is the first. I'm very, very pleased on behalf of Anirudh to make an announcement about our Jasper Gold formal verification platform. So the reality is that there's a lot of real estate available in advanced nodes. And so you are developing your own proprietary IP that you want to use on multiple chips. And so you want to make sure that that RTL is really high quality and that you can make it portable and robust. And you don't want to wait until you get to the implementation or the netlist stage in order to discern whether or not you have an issue. And so therefore, we're bringing our Jasper Gold platform into the RTL sign-off world with 2 new apps, Clock Domain Crossing and SuperLint. And it's been done in partnership with leaders here in Europe, ARM and ST, and we're very thankful for their support and their help on this. And the results are dramatic. So I strongly encourage you, while you're at the show today, to look into these new apps for RTL sign-off that we just announced today. When you're designing a next-generation SoC, or for that matter, next-generation product, it's all about how am I going to partition the software and the hardware, and then as both kind of get refined toward the end of the development cycle, how do I bring them together and make sure that they're working as a single unified product? And the long poles in the tent, we know. It's software development and it's verification. Those are the 2 long poles in the tent. And so Cadence is working and continues to develop and innovate and invest strongly in hardware acceleration and an FPGA prototype. We introduced a new platform last year, Protium S1. For your SoC hardware teams, Palladium Z1 is the industry leader. It's incredible, the throughput of this machine for driver development as well as SoC development and maybe just to boot the system. But your software development teams have to move at a much faster pace. They need higher performance for the middleware, for the apps, for the operating systems. These 2 systems are congruent. They share a common environment. And so both teams working together on these hardware platforms can allow you to accelerate your product to market. The center of expertise and excellence for mixed signal design has always been EMEA. It's always been Europe, driven by so many powerful companies. And you have forced us, I think, over a lot of years to get the open access database with Virtuoso and Innovus to work together for design, and of course for our digital and analog simulators to work together for simulation and verification. But that's not enough. And this new world is challenging us, especially in the world of automotive, to do things differently for mixed signal design. So that includes, an automotive product has a harsh environment. It has a long life, 10 to 20 years. And so reliability is key. And so we're working on new technologies like electrically aware design and REL Expert to extend that and to help you prove that that works. It's not just low power devices. It's high current. It's voltage power MOS devices for actuators, for motor control. And these require Voltus Phi and similar solutions which we're integrating into the mixed signal solution to meet your needs. For those ADAS types of applications, of course, advanced node Innovus and advanced node Virtuoso. For high yield, for optimization, to ensure traceability and functional safety compliance, new tools like ADE Verifier integrated into the digital world. So I don't know how many device physicists are out there. I'm one. So all of us know that we have been chasing Moore's law for a long, long time. I started in 1981 in semis. We're down now in production at 7 nanometer, test chips now at 5 nanometer. We'll get to 3, we'll get to 2, we might get to 1. That's it, right? Just all you have to do is look at the fundamental atomic structure and you realize that CMOS is not going to scale beyond that. So then it's a question of multi-die, multi-technology, something very exotic, or 3D scaling, right? And it seems like most semiconductors today that are doing advanced node and most of their design teams are looking at these alternatives. Increasingly, wafer scale packaging is moving into the domain of the IC designer, both for design and for analysis. And that's why we're trying to merge and bring information from the package and board and system world as early as possible into the design cycle. You'll hear more announcements about this pretty soon. But for instance, inside the Virtuoso platform, we're pulling in DRC and LVS. We're pulling in Allegro and Sigrity technologies. So while my chip is still open, I can actually import actual package parasitics and board parasitics. And I can understand whether or not that signal across all of those fabrics, chip, package, board, and system, will perform at the spec that I need. It's not just about the chip. It's about the product overall. Last year, we introduced a companion technology already in this world at the floor planning and pathfinding level. So for instance, while I'm envisioning my product, I'm going to have to make some decisions. How am I going to optimally locate I/O locations? How am I going to, and which package variants will I choose for different types of designs or different types of products that I'm going to put out? How do I make sure that those signals and those high-speed buses from the chip across through the package, through the board, and into maybe the chassis will actually perform? And I can minimize the number of analysis requirements, crosstalk, and other problems that I might have. And that's what Orbit I/O is about, allowing you to kind of draw that high-level floor plan and then use that floor plan to drive the detailed implementation into Innovus, Virtuoso, SIP layout, and Allegro PCB. Incredibly successful within a year. Again, everything being driven by your needs to transform the world as we know it today. The same thing is happening on the RF side of the equation. Radios are every place, inductors are every place in the designs that we see, whether it's at the chip, package, or board level. A lot of RFIC design is done in Virtuoso. Of course, Spectre RF for simulation, and for package and board, Allegro is very, very popular. We introduced a 3D EM, electromagnetics tool, last year from our Sigrity group, but we're not satisfied having it as sign-off. We want to move it as early in the design cycle as possible so you can minimize the impact of electromagnetics all the way through the chassis ECU level. Wafer-level packaging is incredible. I'm watching TSMC invest billions and billions of dollars in next-generation packaging technologies, CoWoS, Info, WOW, or wafer-on-wafer technologies. So the chip world, as you know it, is going from a planar world and a coplanar world into a 3D world. Of course, the package and the board have always been at that world. And so You have choices now of how things are going to unfold, but what's absolutely key to this is that we can enable adaptive meshing, and we can enable advanced modeling, and that we can enable lots and lots of analysis, whether it's signal and power, or EMIR, electrostatic discharge. The second half of this year, we'll announce a new product solution across chip, package, board, chassis ECU for thermal analysis, driven entirely by the electronic side of the equation, ultra fast, and including computational fluid dynamics at the system level. So Cadence has benefited from a wonderful connections program and a great ecosystem that includes foundry relationships with Samsung and TSMC that have been outstanding, great partnerships with ARM. Those foundries and ARM use our tools to a significant extent, but that's not sufficient for your needs. And so for this expanded world of system design enablement, we're joining standards organizations and functional safety organizations. We're working with software companies and system design companies. We're investing in photonics and partnering with mechanical and more in RF. Last year, we introduced a co-design flow inside of Virtuoso for photonics design with electrical IC design. Of course, photonics is key to those server communication links between the chip to move all of that data. We're doing it in such a way that we're partnering with Lumerical and Phoenix Software to develop this, and we're bringing the technologies of analog such that we don't have to live in a world for photonics design where it's kind of design, build, test, and then design again. We're introducing, just like we did in analog, schematic design, hierarchy, linked logical and physical simulation, and more. And yet another very different example, in December of this year, we announced Cadence's first cloud product, OrCAD Capture on the cloud, available on Arrow.com. Now, I didn't say available on Cadence.com, I said Arrow.com. So why would we do that? Because all of your components are on large players like Arrow. And so if I'm an IoT maker any place across the globe, maybe coming out of a university, I'm going to design probably my first board, and I'm going to look at components, and I can go to Arrow.com, and I can go in OrCAD Capture, and I can look through millions and millions of components, data sheets, reference designs. I can check availability of products and cost. All of that is key to making sure that my next generation smart IoT product is available. This was featured at the Consumer Electronics Show in Eureka Park, which is the startup area. And it was featured with IBM Watson. And it was featured with Indiegogo. Indiegogo is doing crowdfunding, right? People across the globe via the cloud investing in IoT makers any place on the globe. Within weeks, we had thousands of new users, right? This is important to you because these people will be your customers. They're becoming your customers. It's important to Cadence to understand the unfolding IoT maker world. Today, in my second major announcement, I'd like to talk about our partnership with MathWorks. So last year we introduced the linkage between and the integration of PSpice and Simulink at the board level. So for system level simulation solutions for mixed signal IoT and automotive applications being driven heavily out of Europe, frankly. Today we're announcing integration of MATLAB embedded inside of the new analog design environment to help link the system design world into the transistor design world. And I'd like to invite my friend and colleague from MathWorks, Arun Mulpur, to come up and tell you a little bit about this. Thanks, Arun.
Thank you, Tom. And thank you, Cadence, for giving us this opportunity to share this exciting milestone and deliverable in this ongoing partnership that we've had with Cadence for the last few years. Many of you are already using, are very close to start using this integrated Virtuoso ADE as your common design platform. And I don't need to tell you that your designs are getting very complex and your simulations are generating enormous amounts of data. And you as designers and design team leads have to make sense of that data process it, analyze it, visualize it. And the good thing is that for many of these designs, MATLAB has already been used together with some of our toolboxes. So imagine sitting inside ADE and being able to open an interactive session of MATLAB without ever leaving the comfort of ADE. Imagine running your observation or scripts that analyze your data right after you are basically done with your simulation automatically. And imagine being able to reuse the scripts from MATLAB or toolboxes that you have already been using. Again, all integrated within ADE. So you don't have to start, imagine that anymore because that's now possible due to the enormous R&D efforts that Tom and his team have put in. That is what is now possible today. If you are already using MATLAB and you have access to some of our licenses, you don't really need anything else from MATLAB or MathWorks. You can use this today. So if you're interested to know more about this, find your Cadence partner, the favorite Cadence person that you like to talk to, or come and stop by the MathWorks booth in the exhibit area, and we'll be happy to talk to you. And we are looking forward to further collaboration with Cadence. Thanks very much for listening. Thank you, Tom. Thank you.
Thank you, Arun. So Andy Grace runs the Simulink area, and Roy Lurie runs the MATLAB area at MathWorks. And this has been, I think we've been working together 3 years to really form a partnership. Again, we see our world changing. We see this world of system design being so critical, and yet we can't do it all by ourselves. And so we're very serious about these partnerships, and it's great that our R&D teams are working together. In this last section of my talk, and it'll be pretty brief, I want to talk about the application of these tools, technologies, these new fabrics, and how it's changing and how it's pressuring the world of kind of the conventional automotive OEMs and suppliers and supply chain today. And I think Davide will actually talk about this as well, and with a lot more insight than I can provide. But these new fabrics are challenging. I can't tell you who, but I was at a large second-tier OEM recently who was doing some design at 350. 350 is huge, right? It's incredible. And they were talking about making the leap to 16. Right? That's an incredible leap to make, right? Why? Because they can no longer be in the old world. That was the term used by the person. We have to move out of the old world into the new world. And so the pressure's increasing. So I started my career at General Motors actually before I entered the semiconductor industry. I could only last about 2 years there. It was so painful back in the late 70s. Then we had a 10 to 12 year development cycle, and they were so excited when they could bring it down to 7 years, right? But the people entering the automotive industry are coming with a consumer background and a consumer bent, and they look at a 2-year development cycle as being too long, right, for a full product coming out. And that includes development of the SoC, all of the firmware, the entire stack up, the ecosystem that goes with that next generation consumer product. Now at the same time, the OEMs are demanding integrated ECUs and better ECUs, right? It used to be there was one ECU per major function in a vehicle. Not anymore. Now the ECU needs to handle safety systems and infotainment and ADAS. And so that puts a lot of pressure on the analysis requirements and the data throughput, on the number of operating systems on that ECU that have to be done. The only way to get there is with new SoCs, with new system and packages, with new modules, and with new miniaturized rigid flex board applications. And of course, again, the same rule applies. Verification and software development are the long poles in the tent. The good news is if you're doing a next generation SoC, you don't start from scratch. You use your own IP. You can pull in bleeding edge IP like our Tensilica, Extensa, and Vision processors. These can be used for audio and for vision applications, for radar, LiDAR management applications. They're all built with functional safety in mind, including error management and isolation and memory and data protection, full documentation for ISO 26262 through ASIL-D. In fact, here in Germany, last year, the combination of our DSP along with a convolutional neural network algorithm on a Xilinx FPGA set the benchmark in Germany for traffic sign recognition better than a human. Now, we've subsequently enhanced the Vision C5 DSP. It's ideal for CNN-type applications. Again, a transformative application that applies more than just the autonomous vehicle, but is rolling out across the globe. I talked about the billions of dollars being invested by foundries now in advanced packaging. You can look at wire bonds on interposers. You can look at through silicon vias for stacked chips. You can look at a plethora of chip scale and wafer level options for doing your design. The whole concept is maybe I don't need that board. Maybe I can have my CPU and my memory, or my GPU and my memory, and I can have embedded sensors, and I can have embedded radios, and lots of software all in a package. What does that do on the power side of the equation? Of course, the analysis side goes up at the same time. Cadence has been designing high-speed boards, both large and very, very small, for a long time, using our Sigrity and our Allegro and OrCAD product lines, and you see how we're reaching out into that IoT maker community. You also see that we're reaching out and extending ourselves into the world of MathWorks for system design and Aero, and with great partnerships with PTC and Siemens and Dassault, Autodesk, and more on the PLM side and on the mechanical side, because the world of electronics and mechanical are coming together as well. If you think about the forward-facing camera module in a rearview mirror that's unfolding in a lot of advanced vehicles today, think about the thermal requirements for that. It's a very harsh environment. It's sitting up against the windshield. How are you going to dissipate the heat? You have the extreme heat in the summer. You have the frigid cold in the winter. Think about the expansion that happens on that module. Think about it having to last 10 to 20 years. These are the challenges that you face and companies face, but they will surmount them using advanced technologies and advanced techniques. Wireless is yet another new fabric, just rocketing into the vehicle, right? And as 5G unfolds, it will rocket even faster. Of course, Bluetooth is there, and now people want to have full Wi-Fi capabilities in their vehicle. The cabling is going to make its way out of the vehicle over time. It's going to be drive-by-wireless, just like steering is done today. You won't even know it, but it'll happen. And Ethernet will be throughout the car. It needs to be secure, of course. But how are we going to get all of that data in and out of the vehicle for the driverless car and hopefully the flying car in the future? It's going to be with silicon photonics. It'll apply in other areas like laser sources and optical connect and optical couplers and the like. That's how we're going to get 25 gigabits of data in and out of that car every hour, and it'll probably double once the initial rolls out. So I live in Pittsburgh, Pennsylvania, because as Sanjay said, my startup was out of Carnegie Mellon University back in the late 90s. It was acquired by Cadence. In Pittsburgh, there's, of course, Carnegie Mellon's robotics labs, and Bill Gates made a nice multi-billion-dollar investment into the software community there. So there's the Bill Gates building, and both those labs are working with a number of advanced companies on the autonomous car, just like in every major city with every leading university. So Google is there, Uber is there, Ford is there, General Motors is there. Some people I can't name are there. Google has more than 1,000 people on this. Uber has 700 people on this in Pittsburgh. There are more than 80 Uber driverless vehicles on the streets of Pittsburgh for almost a year now. And I've ordered Ubers in Pittsburgh. You don't know if you're going to get a driverless one or if you're going to get a driver one, right? And if you get the driverless one, there are 2 occupants in addition to you, right? There's a software engineer and there's, a backup driver. And just ask them a question about what's going on, and you'll come to the conclusion that they're mute. They will tell you nothing. On the top of those vehicles is this large mechanical rotating beacon. It's a big LiDAR system, right? LiDAR is so much better for recognition of objects than cameras or radar, right? That LiDAR system is in excess of $50,000 per vehicle. That is not sustainable. We know that, right? That's not going to be the driverless car, right? It's going to be a new fabric. It's going to go solid state. You're probably working on it, right? It's going to drop by orders of magnitude in cost. It's going to go up in terms of reliability by orders of magnitude, all because of new fabrics. It's going to be using MEMS mirrors on a custom IC, scanning thousands and thousands of data points per second with high precision and high reliability. And that's why we reached out a few years ago and did MEMS integration with Coventor inside of Virtuoso so you can do co-design. Again, the opportunities are not going to stop. They're just endless. So this is my concluding slide. Robert Frost was a famous American poet who penned these words more than 100 years ago. If you had a school teacher for a mother who was into literature like my mother was, then you learned a lot of poems. This is one I learned. Two roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. So men and women like William Shockley and the Shockley 8, they have really ushered in the opportunities we have today. And for the next generation, you're going to usher in the opportunities to transform the world as we know it today and to lay the groundwork. But you can do that by looking outside the box, by taking that road less traveled. It may have a few, maybe less clear. It may have a little bit more risk. But I hope I've inspired you to think about next generation fabrics and how they may apply. And I do hope that in my lifetime, little Tommy may just get his flying car after all. Thank you so much. You've been a great audience.